are going to cover up the whole object-oriented programming with C++ in single video. First, I'll show you the outline which I'm going to cover. Initially, we will going to start with the introduction to OOP. We are not going into history, evolution, and need of OOP. We will just going to see what is procedural programming and what is the difference between OOP and procedural. So it's a practical class, it's a lab class, so in this video we are not going to deep dive into UML basics and UML classes, okay, and UML diagram. Then we will going to cover abstraction and encapsulation with the help of, before abstraction and encapsulation, we are going to discuss objects and classes, what is object, what is classes, how to create objects and classes and all. Then we will move forward towards the second part, which is abstraction and encapsulation. Then we will see what is abstraction, what is the definition of abstraction, and what are the use cases of abstraction, why we use abstraction. Then we will see access specifiers, getter setters, structures, constructors and destructors. Then we will see class members, advanced class members. That's the heading of this week basically. We will see static members, inline functions, array of object, how to create array of object and what is the use of array object. Then we will move towards polymorphism, overloading concepts, runtime and compile time polymorphism, function overloading, operator overloading, friends function and classes. That's not the complete coverage of each topic in this week. We will going to cover polymorphism, runtime and compile time in depth in the upcoming topics, in the upcoming weeks. That's a crash course. Basically, this outline is designed according to 4 months, but I'm going to cover this outline in single video. Then we will see about polymorphisms, overloading concepts, function overloading, operator overloading, friends function and classes. Then we will move towards inheritance basics, types of inheritance, classes, class relation. Now we will going to skip this class relation part, the UML concept, okay. We are just going to see the relation between the classes in inheritance. In each type of inheritance, what type of relation and what type of communication or connection occur between the classes. Then we will see advanced inheritance, multiple inheritance, diamond problem, virtual inheritance and all. Polymorphism. We will going to cover the depth of polymorphism here. Then we will going to see some basic examples how to do exception handling, just a basic format, how to write exception handling and all. That's the whole outline which we are going to cover in this video. And in earlier videos we already covered the GUI part, the CRUD mini project, CRUD operations, and we will see the filing concept in another video. Okay, that's the whole outline which we are going to cover later in this video. Now come to the end. I'm using Visual Studio for the coding purpose. Okay, first we will see like why do large software systems fail when a small change is made. That's a question which will going to explain the base concept of OOP and use of OOP. The answer for this question is because they are built around functions. Building something around functions, it's a procedural programming, and not with real entities. Object-oriented programming was created to solve this exact problem. In procedural programming, we only work on functions and data separately, like they are not connected. They both are separate entities, and there's no kind of link between these entities. But if we talk about OOP, OOP contains four pillars, which is inheritance, encapsulation, polymorphism, and abstraction. These four pillars are real entities, like these four pillars considered behavioral entities. According to these pillars, and by implementing these pillars, we ensure that the code runs around real formation, real entities, not with just functions and datasets. In OOP, we link data with behavior. Now just take an example and learn this topic through an example, and just understand what is procedural programming and how does procedural programming looks. That's the basic body of C++, which we are going to follow and to use in the coding videos. Now just start with the understanding of what is procedural programming, how does it look. We just created two variables. If you want to learn the basic, you can see the previous playlists about C++ and basic programming. I created two variables with name and age, and then created a function for set data. Actually that's a getter setter, in which where I feed the values in these variables. Now just take an example with Alice, and the age will be like somehow 16. Okay, then void show data, where I directly display the values which I've taken earlier and saved those values into the variables here. Now just see, I created two global variables, and then I created a function to set data into those variables. Then I created another function to display the data which I've saved earlier in the above variables. Okay, that's what a getter setter means. It's a setter. And now what we will do here is we are just going to call our variables in our main function so that they can display, they can execute. Keep that in mind. Look, what I've got is name as Alice and age is 16. Keep that in mind. Writing any function above the main function will not be included into the program unless you call that specific function into the main. If you want to display something or execute something, you have to mention that function into main. That's the basic procedural programming. Pause the video for a couple of minutes and think about the problems in this code and problems which will occur by the use of this code. Now, the data is global. Anyone can change it. No structure and hard to maintain. It's an empty line of code, so it seems easy to change the data. But if the number of lines and the complexity of the code increases, then all these issues will occur and all these problems will occur. So in OOP, everything works around two things: class and objects. And you can say here we call data as consider data as an attribute and functions as a method. Okay, just start with creating a class. We are going to understand what is class and what is data, how these things work, and how these functions work later in that video. Okay, we are using access specifier, in which I am creating a variable, creating two variables basically. One is for name and another for age. Now create a function in the same class to set data. Where I will just going to update the values Alice, and again his age is 16. Okay, now we are going to create another function to show data, and that's the basic practice for class. After declaring the class body, you have to mention the semicolon. Now again in main we are going to execute this class which we wrote earlier. For now it seems similar with the above code, but I'll explain later what is the difference between this code and the above code. Okay, keep that in mind. If you are creating any variable or any object, make sure to use or to name those variables meaningful, so that later after some time when you visit the code again, you know what does that specific variable mean and why did you create that variable. Just consider I created a student class, and I'm just going to create a object for that specific class, and I just name it xyz something. If I visited this code after a month, do you think I can get easily what does that specific variable do? No, it would be hard for me to understand and to rewind what did I do in this code and what does that specific variable do. Now with the, let's just name it student1, and now with the student1 I'm just going to set data and then show data. Right now these two functions are hard coded, but later on we are going to take user inputs and then update the values, so that we can create multiple objects of each class and update the multiple values. Now this piece of code and this piece of code perform the same functions, but the difference is this code is more structured, more organized, data belongs to its objects, easy to extend, and secure and reusable. Now what does these means? Code is organized, as you've seen that the code is clearly organized. Now there are no global variables, and we are like we created a class for students where we created two functions to set data and to show data. Okay, now we updated the values same we did earlier, but the difference is we are doing everything in a single body, in a structured way, in a formatted way. Now we know what does these blocks do and where does these blocks belongs. Okay, now we created an object, and for that object we updated these values like the name Alice and the age, these both values, and that's a single student entity. If I want, I can like duplicate these entities to reuse it. Okay, I'll show you the magic now. Now as you seen, I've created the same function, I uses the same class, I just changed the object name and I recall that object again, and I call these functions again. Here we are doing reusability through this class and through these objects. Okay, come to the class and objects which we've done here. What does class mean and what does object means? Okay, consider class as a blueprint. What does a blueprint do? It's an architecture, it's a structure, and blueprint explain how it should be built. If we consider an example of a car and class is a blueprint, then I created a class. I created a class for car and name it car. Okay. Now here I'll describe what will be the properties of this car and everything. Okay. Right now I'm not doing anything else. I'm just mentioning some attributes of this car. As we discussed earlier, class is a blueprint, an object is the real instance of a class. You can take an example like if we are going to discuss, if we are going to understand the difference between car and objects and what does actual meaning of car and object is. Consider car as a blueprint and just leave car. Come to the building. Consider before developing a building or before constructing a building, first we created a blueprint. How does this building look? A map, a structure where we explain the floor, everything, and then once the blueprint is completed, then we follow that blueprint, and by following or by mapping that specific blueprint, we created the or we constructed the whole building. Then consider that building is an object, an actual car, an actual building, and you can object instance. If we map this example and this concept, first I'll explain like the actual meaning. Okay, this blueprint have two objects, number 1 and number 2. Okay, this blueprint contains 4 attributes, which is color, and other one will be float, weight. Okay, and other one will be mileage or the type. Now here I'm going to map this with SUV, and what will be the another type of the cars? Let's do some searches. Hatchback, coupe, sedan. One is SUV, another one will be it's sports car. Okay, still these two are generic objects. Like these two objects contains a lot more different types in it. But to understand this concept, we are just going to take this as an example. Okay, this blueprint contains three attributes, and these three attributes will be going to apply on each object. Now the SUV dog color will be red, SUV dot now did you see? Here's an error. Why? I did everything right correctly, then why I'm facing this sort of error? Okay, here I updated the values. Now what's the issue? Same here. I'm going to do with the sports car color, weight, and then type. Coupe car, you can just take an as in Ferrari. Why these errors? If I'm trying to run this or execute this program, it shows there will be build errors. Would you like to continue and run the last successful build? Why? The issue is by default class access specifier is private, which means if I forget to mention this, then my class attributes and properties will be considered as private. Okay, and I cannot access these properties outside this class. Now if I try to execute this program, it will execute successfully. Now why there is no display here? The main reason is I just updated the values here and they display the value and didn't write any piece of line to display this or these properties and these values. Okay, that's the basic example. What is class and what is object? Now for you I have 4 or 5 questions related to this topic. First question is, why was OOP introduced? You have to do this research for your general knowledge. Second question will be, write two or three differences between procedural and OOP. What is class? What is object? And give 4 real world examples of objects. Okay, that's all for this class. Now we've covered these topics: history, evolution, and need of OOPs, procedural versus OOP, and real world modeling through objects and classes. We've already created objects and classes as well. Okay, now you have another task to do is you have to create a class with these attributes and objects of the class, and create 3 different objects of the class and set the values for the attributes. Okay, that's our question 1. For now, question 1 will be enough. Now we are going to cover these topics: abstraction and encapsulation, access specifiers, carrier setter, constructor, and destructors. Okay, just take an example and just take a real world example. When you use a mobile app, you only see buttons. Did you ever see the complex code behind those buttons while using and on the user interface? No, never. That hiding of complexity is called abstraction, and protecting data is called encapsulation. Abstraction means showing only what is necessary and hiding internal details. Another real world example is ATM. When you withdraw, you only see the balance, not the logic behind that function and that operation which you've performed earlier. Okay, now understand this topic and understand this concept with the help of an example. I'm going to create a class with the name of ATM, and here I'm going to use the public access specifiers, where I'm going to create a virtual function. What is virtual function? We are also going to understand this concept later in this video. Okay. Now I've created an other class and inherit this class. This specific line is the example of inheritance. We created a class bank ATM and inherited that class with the ATM class, okay, which we wrote earlier. Now again we are going to cover this specific topic later in this video. For now, just understand the concept of abstraction through this code. Forget virtual, forget everything, just understand the concept through this code. Void withdraw int amount. We use sin for user input and cout to display anything. That's the basic C++ concept which we've learned earlier in basic programming. Okay. Now withdrawing amount from bank. Now the simplest way to perform anything here is, again, I've called the class here and then created a object for the specific class, and then I call that withdraw function. Just updated the value here. It's a parameterized function, okay, and through parameterized function we have to pass the specific parameter which required earlier to execute that specific function, okay. And in another class we are updating the values and we are displaying the values here through a proper execution and proper formatting. With a proper formatting, now in main we just have to provide the value. In main we just have to provide the value so that our program execute cleanly. As you see here, withdrawing 500 from bank ATM, okay. That's the example of abstraction, okay. We created the abstract classes and we only showed the final execution without calling and without displaying everything publicly. Now come to the access specifiers. We are going to see more examples for abstraction, but before that, come to the access specifiers. We have three access specifiers: public, private, and protected. Public, we can access attributes written under public like this, public this, and you can say int age from anywhere, and we only access this attribute, this age attribute, which is returned under private access specifier, only inside the class. That's the difference between public and private. Now come to the protected. We can access age1 from anywhere, we can access age2 only inside the class, and we can access age3 inside the class, and also we can access age3 from the derived class from that specific class. Okay, that's the basic understanding what is access specifiers and how can we access these parameters, or how can we access those attributes which written under each access specifier. Now what does getter setter do? Come to the getter setter. Getter setter protects the data, validate input, and control access. Like in our previous example, we are getting and setting the data. This specific function is getter and this specific function is setter. Like we are setting the values into these variables through that set data function, and we are getting the values from those variables through setter function. Okay, that's the basic understanding and practical use of getter setter. We've already discussed the example earlier, so we are not going in so much depth of getter setter, because in later video we are using getter setter so much. Now comes to the constructor and destructor, and why we prefer constructor over functions, and what is the difference between constructor and function, what is the key execution format of constructor and destructor. Okay, first create a constructor, then we will explain this through that example, explain this concept through that example. Okay, to create a constructor, first I have to create a class, then after that, first I have to create the class, then I have to create a constructor. It's basically a function which operates, and it's same as function, but the difference is we can name, and if we are going to create a function, we can choose any name for that specific function. But if we are going to create a constructor, the first rule is the name for that specific constructor have to be similar with the class name. Okay, the difference between constructor and function is constructor runs automatically when I created a function, I created an object for that specific class. Okay. Also, destructor runs automatically when object is destroyed. I'll explain this concept a bit later. First, I'm going to create a destructor. Now, this specific symbol differentiate between constructor and destructor. It's a destructor for that specific constructor. What does this piece of code means? It means first create a class, then in class I created two functions and two constructor. One is constructor and other one is destructor. Keep that in mind. I'm just referring that to the simple words. This constructor is creating a class, file created, creating a file created. Once the file created, and I just consider and putting some values into that specific file, and those values are successfully inputted and updated in the file. That specific function, that specific constructor is utilizing the memory. I have to release that specific memory. So to release that memory or to delete that function, delete that occupation, I create destructor just to release the memory. Okay. These two are the major differences between a function and a constructor. Now if I create main nama file, as you see here, I just created an object here. Okay. Earlier I have to call that object, I have to call the function through the use of that object, then I can return the values. But here I just created the object. My constructor automatically executed, my destructor automatically executed and show me the final input and final output for these two functions: file created, file closed. Okay. That's how the constructor and destructor works, and that's how a constructor created. Now also we are going in depth of constructors and types of constructors a bit later. Now come to the encapsulation part. In encapsulation, I've created a class bank, then using private access specifier for balance, then mentioning public access specifier, created a constructor in which I'm just going to update the value of the balance, which I've made private. Okay. Void. I'm writing a function for deposit. Amount in terms of, in short term, I've written the AMT. In amount, I'm going to check if amount number is greater than 0, then balance, which is this one, update the balance with that specific amount. The example is like if a person type 500, that 500 came here in if condition and check 500 is greater than 0 or not. If 500 is greater than 0, then the balance, which is right now is 0, okay, equals that plus equal operator means balance plus the amount. Now for now in our case the amount is 500. That's what this specific function do. Okay, now after that we will be going towards creating another function just to return the balance, or just to display the balance basically. Now bank B, let's suppose I'm the user and my initial bank account balance is 50,000. Okay, and I'm going to deposit 50 more in my account. Okay, now my total balance will be, and I'm going to check my balance. So my total balance is b dot get balance. So as you seen, my total balance is now 1 lakh rupees. Okay, now come to the example. Understand this piece of code and understand this code. First I created a class in which I created a single attribute private through access specifier. Then I created some public functions. That's my setter to set the values for this attribute. I wrote a deposited function in which I'm just going to check whether the amount is greater than 0 or not, and then I'm updating that amount into my current balance. That's my current balance. Now just update the name of that variable. As I've told earlier, to use meaningful names. Okay, so now that's my program, and here I'm just going to deposit the amount and updated my current balance here. That's for setter. For getter, I'm just getting the values and getting the amount which I've updated earlier through this function, and I'm just getting through this. Okay, in main I've updated my initial balance. Then I deposited the same amount, just rechange the amount. Okay, if I execute it again, now you see my total balance is 90,000. That's the perfect example of encapsulation. Balance is hidden from the outside access. This specific property is hidden, and this property only accessed by the bank. No other person can access this property and can change the values of this specific property. Okay, this specific attribute. Balance is hidden from the outside. I use constructor to set initial balance. Now here, first validation, first we validate the value, then updated that value and deposit that value into my current balance. Then this function is the example of getter. I'm getting the values. First the object created, object which is b, value updated, deposited added, and balance displayed. That's the example of encapsulation. I'll share this specific file with you. Now come to the advanced class member topic. Then we will move towards polymorphism, overloading concept, runtime, compile time, and everything. Okay. Now we will move towards these topics, but before that, we have some types to discuss of constructors. Okay, we have three types of constructors. First one is default constructor, which is class person, then that's my constructor, that's my default constructor. If we come towards parameterized constructor, copy that example, here add. That's my parameterized constructor. Here what I'm doing is I'm taking a parameter and I'm taking a value from the user in this constructor. Okay, now another one is these two are the major types of constructor. these two are the major types of constructor which we used in this program and which we used in real-time world or during coding and all. Also, we do constructor overloading, but that topic is the power of polymorphism. We will discuss it here now. It's a power of polymorphism. In polymorphism, we do overloading, overriding, function overloading, constructor overloading, and all. Okay. Now again, create a class public. Now I've created a class in which I created a constructor. That's my default constructor. Okay. Now, as you see here, in single class, I've created two constructors with the same name. Did you ever practical to create two methods with the same name? Your program will automatically declare error. But in constructor, this one is the default constructor without arguments, without parameters, and this one is parameterized constructor. Okay, that's what constructor overloading means and constructor overloading do.